Okay, hello everyone. My name is Fatya Azizah. People usually call me Fatya. With last three digits of my name is 054. So today we're gonna talk about injection, surjection, and bijection. Okay, but before we start our main topic, I'm going to show you how to draw a graph of a function and also how to simply get the graph of a function using GeoGebra. So I have my tablet in here, so I'm going to look down. Okay, so in here we have a function, example of a function. So that is function from real number set to real number set where f of x is defined by 4x minus 5 over 2. And we want to make a graph of it. So all you gotta do to draw a graph of this function is you have to take a sample set of the domain. Take a sample set of the domain. Okay, and find the output of each of the domain sample. This is the output. So we have the sample set of the domain we take in here where we can use a table. We can use the table to see the domain and the range simply. So we have the set of the domain here. This is just the sample of the domain. Actually, the domain is real number, okay? And then we have the output. We find each of the output. Okay, we substitute each of the domain to the function, and we got this. This is the output. Oh, I'm sorry. This is minus. So this is the output. And after we get the output, we have the coordinates. Coordinates will be x, comma f of x. Okay, so we have this. This is the coordinate. This is the coordinates that we have. And then after we get the coordinates, we place it to the graph. So the first one, I'm going to draw it in here. So the first one, we have 1 point minus 0, 0.5. So it will be in here, I'm sorry. Here, 1, minus 0 0.5. And then we have 2, 1.5. Here, 2, 1.5. And 3, 3.5. 3, 3.5. Okay, so and then we can make a line of the coordinates that we have like this. So we can like this. Wait. Yeah. So voila, the graph is now done. It's pretty simple. It's pretty easy to make, right? But it's so much simpler if we use the GeoGebra to get the graph of a function. Okay, I'm going to show you how to draw a graph in GeoGebra. Yeah, this is the GeoGebra look like. Okay, this is the screen of GeoGebra. And all you gotta do is just input the function in this side. Okay, input the function that we have 4x minus 5 over 2. Wait, over 2. And voila, we have the graph. It's really easy. It's pretty simple. It's so much easier, so much simpler to make a graph. We also can draw any graph that we want, right? We can also input like, for example, x square of x minus 1. And we have this. This is the graph like this. We can zoom it and zoom in and zoom out like this. And yeah, it's so much simpler. Okay, we're gonna move on to the injection, surjection, and bijection of a function. The first one is the definition. The definition of injective function, or we call it also one-to-one of a function, is function from, if we have a function from A to B, the injective function or one-to-one, just if and only if for every x1, x2 element of A, where x1 not equal to x2 implies f of x1, f of x1 not equals to f of x2. And then the surjective function or onto, if we have function from A to B, the surjective function will be complete if and only if for every y element of B, there exists x element of A implies f of x equals to y. And then the bijective function, if we have function from A to B, the bijective function will be complete if and only if it is one-to-one and onto. So the bijection will be complete if the function is injective and also surjective. So if the function is injective and also surjective function, then the function is also bijective function. Okay. Okay. And then the simple way to memorize is the function that onto is all of the element of codomain are the range. And then the function that is one-to-one is there's no two or more x that has the same value of y. Okay, so we're gonna move on to the proof of bijection. Why bijection? Is if we prove the bijection, then we can prove the injection and also we can prove the surjection. So if you want to know that a function is bijective, then we have to prove that the function is injective and also surjective, like what I said before. Example 1, given f, given function from real number set to real number set, prove that f of x is equal to 4x minus 5 over 2 is a bijective function. So first step is proof of injection. So we have to prove that this is the injective function or one-to-one. Okay, first step is take any x1, x2, take any x1 and x2 that is element of real number set, where x1 not equal to x2. And it will implies f of x1 is equal to 4x1 minus 5 over 2, and f of x2 4x2 minus 5 over 2. And it's clear that f of x1 not equal to f of x2, right? It's really pretty clear. Then we get for every x1 and x2 element of a real number set where x1 not equal to x2, it implies f of x1 not equal to f of x2. So we get the definition of the injective function. So this is an injective function or one-to-one. And then the second one, I'm sorry, this have to be the second step is proof of surjection or onto. So the first step is take any y element of real number set. We choose x is equal to 2y plus 5 over 4. It implies f of x, it equals to that. So we find the output, then we got y. So f of x is equal to y. Then we get the definition of a surjection. So for all y element of real number set, there exists x element of real number set implies f of x is equal to y. So this is the surjective function or onto. And from 1 and 2, because this is one-to-one and also onto, then we can conclude that this is a bijective function. Okay? It's pretty easy, right? So this is the graph. This is the graph of a function. It's familiar, right? Yeah. So um draw the draw the graph before this. Okay, next. Okay, okay. Next one is proof of bijection. Example 2. Given f, given function from real number set to 1 until infinite, or y is greater or equal to -1. Prove that f of x equals to square of x minus 1 is a bijective function. So we want to prove this, but it's not actually will be bijective. So if this is not a bijective function, that we have a conclusion that this is not a bijective function. Okay, so the first step is proof of injection. Take any x1 and x2 where x1 not equal to x2. We choose x1 is equal to a and x2 is equal to minus a. We want to make a difference of x1 and x2, right? So it implies like this. So it implies f of x1 is equals to f of x2. Then we get there exists x1, x2 element of real number set where x1 not equal to x2 implies f of x1 equals f of x2. So this is not an injective function. Okay, so this is not one-to-one. It's actually, we can just stop here and make a conclusion that this is not a bijective function because the injection is not required. So this is not a bijective function. But if we want to learn how to prove the surjective function also, so we're gonna continue the proof. So the second one is proof of surjection. I'm sorry again, that is actually second step. So take any y greater than -1 because it's given in the question. And then we choose x, it's equal to a root square of y plus 1. From this, it's clear that x greater or equal than 0 and y greater or equal than -1, and it implies f of x is equal to uh, like that. And this is obviously implies we have the square, we have the root square. So the root square is can't be minus in the inside of the root square, right? So the f of x will be the values of f of x will be greater or equal than -1 because 1 because y is greater or equal than -1 and f of x is greater or equal to -1. We also have this, yeah, we also imply it to the function. Then we have f of x is equal to y. Then we get this. So we get the definition of a surjective function. So this is the surjective function, or this is we can conclude that this is the surjective function or onto. From 1 and 2, because it is not 1-to-1, and but this is onto, then we can conclude that this is not a bijective function. Okay, and then this is the graph of a function. Yeah, this is the graph of a function like this. So that has of two different x that there exists one values of y like that. So this is the surjective function, but this is not an injective function. So this is not a bijective function. Actually, this can be a not a surjective function. Okay, if the codomain have no limit. If the codomain is the real number, then this is not a surjective function. But in the question, in the example question, we have the limit of the codomain. So all of the codomain are also the range. So this is surjective function, like that. Okay, that's all from me. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.